Welcome back to This Explainer. Every single day we see digital AI making these absolutely massive leaps. But when it comes to the physical world, well, progress has kind of hit a massive wall. Today, we are decoding the exact bottleneck holding back the physical robotics revolution. We're calling it the AI Data Starvation. And honestly, by the end of this, you're going to see the future of robotics in a completely different light.
It's the ultimate question, isn't it? If AI is so incredibly smart, why don't we have robot butlers yet? Why is our cutting-edge home robotics mostly just, little plastic discs that aggressively bump into our furniture? Well, the answer isn't a lack of processing power or better metal joints. The truth is, the embodied AI field, which is really just a fancy way of saying putting artificial intelligence into a physical moving machine, is absolutely starving for data. Specifically, it's starving for high-quality, real-world robotic data. And without it, the smartest AI in the world is essentially paralyzed.
Okay, let's dive into this. To really understand how the industry is tackling this data starvation, we're going to use a concept called the data pyramid. First, we'll look at the AI data starvation itself. Then we'll climb into layer 1, real robots. After that, layer 2, simulation data, and layer 3, human video, before wrapping it all up with the data flywheel.
All right, kicking things off with section 1, the AI data starvation, which really is the critical bottleneck in physical AI. We really need to set the stage here, because sourcing data for a physical robot is fundamentally harder than training a digital AI model. Think about it. When tech companies train a massive language model, they effectively just feed it the entire internet, right? Millions of books, articles, websites, it's all right there. But physical AI, it completely lacks that raw material. Sourcing high-quality robotic data is extremely difficult. You can't just download a PDF on how to gently pick up a cracked coffee mug. The robot has to learn how to operate in a real, physical environment that's completely governed by gravity, friction, and, let's face it, unpredictable human spaces. Moving right along to section 2, layer 1, real robots. This is the expensive pinnacle of the pyramid. Up here at this top layer is where the absolute most premium data is born. Human operators essentially put on VR headsets or grab controllers to remotely operate real, physical robots, doing tasks over and over and over again. They record every single sensor, every tiny joint movement, every camera feed. Now, the pros here are undeniable. This provides the absolute most complete, authentic, ground truth information you can get. It's the core raw material for deployment. But the cons are massive. It is painfully slow, prohibitively expensive, and you simply cannot scale it exponentially because you are physically bottlenecked by how many robots you own, how much facility space you have, and the limits of human labor.
But listen, the industry isn't just giving up on this layer. We're seeing a major trend emerge right now, particularly with these massive data collection factories being built in China. Companies over there, like Ajiget Zuyan, are attacking this exact bottleneck head-on. They're leveraging localized labor advantages to literally mass produce this premium real robot data at an industrial scale. It's a really intense, brute force approach to feeding the AI exactly what it needs.
Let's move to our next section and see how this builds. Section 3, layer 2, simulation data. Training AI in the infinite virtual world. I mean, if the real world is too slow and way too expensive, why not just train the AI inside an infinite virtual world? This middle layer of the pyramid involves training the AI inside highly detailed physics engines. And the upside here is absolutely breathtaking. Infinite scalability. Inside a computer, you can generate millions of super rare edge cases that would be way too dangerous or just too difficult to capture in real life. Imagine trying to get a robot to drop a glass jar 1,000,000 times in reality. That's a total nightmare. But in a simulation, it's literally just code. NVIDIA is making massive bets on this route. We've actually already seen incredible breakthroughs, like a robotic arm that learned to play ping pong against actual human players, and it was trained entirely in a pure virtual simulation. Crazy, right? But there's always a catch. And in this case, it's what we call the fatal dual gap. So, on one side, you have the sim to real gap. This happens when an AI learns perfectly in a sort of video game environment. But the moment you drop that virtual brain into a real robot, the policies just break down because real-world physics are so unpredictable. Then, on the flip side, you have the real-to-sim gap. And this is the immense engineering nightmare of trying to accurately model our chaotic, messy, highly textured real world into a pristine virtual engine. A slight breeze, a smudged camera lens, a gear that's just a tiny bit worn down, those things are incredibly hard to simulate perfectly.
All right, dropping down to Section 4, Layer 3, Human Video, the messy, massive foundation.
So, since real robots cost a fortune and simulations are, fundamentally flawed, we have to turn to the most abundant and lowest cost raw material available to us. We're talking about the billions of hours of human-centric video already out there, sitting right at the wide base of our data pyramid. To really grasp this layer, we got to understand a crucial piece of industry jargon: egocentric video. It sounds complex, but it simply means first-person perspective video. Think of a GoPro strapped to someone's chest while they cook dinner or clean a house. By feeding this massive scale of video into foundation models, the AI builds basic physical cognition. It starts to understand how the world works, it develops spatial reasoning, and crucially, it learns to understand human intent. It watches millions of people open doors, and suddenly it clicks, okay, so that's how a door operates. But here's the kicker. While this video data is practically infinite, it has a major downside. Human video completely lacks force, torque, and tactile feedback. A video camera only captures the visual results of an action, right? It doesn't capture the exact electrical motor signals, the muscle tension, or the grip strength needed to actually pull it off. Because of this, the AI learns what to do, but it literally has no idea how to move its robotic joints to achieve it. Now, what's really fascinating here is the massive geopolitical and strategic shift this limitation is causing. Silicon Valley pioneers are aggressively pivoting to this video foundation. You've got companies like Physical Intelligence, Figure AI, and Sunday Robotics, plus huge projects from Apple with EgoDex and NVIDIA with EgoScale. They are all jumping on this. They're trying to combine reinforcement learning with massive crowdsourced egocentric video collection to completely bypass that heavy, expensive teleoperation from Layer 1. They are placing a massive bet. If they can just extract usable action signals from cheap human video, they win the entire race. Which brings us to our final stop, Section 5, the data flywheel, bringing the pyramid together.
Here is the absolute secret of the robotics industry right now. No winning AI model uses just one layer of this pyramid in isolation. To win, you have to bring the whole pyramid together. It's a high-stakes balancing act. You've got real robots giving you authentic truth, but they're bottlenecked, which is driving the trend of data factories in China. Then you have simulation offering infinite scale, but it's fighting that fatal dual gap, leading to intense virtual breakthroughs. And finally, you have human video, which is super abundant and cheap, but lacks physical feeling, fueling the massive Silicon Valley pivot. The whole thing is a global race to balance these distinct pros and cons.
So how do we actually get these robots into our homes? Well, it requires a 3-step flywheel. Step 1, you got to figure out how to extract high-signal action data from that vast ocean of low-cost human video. Step 2, you apply that knowledge to cheap, continuous deployment loops in the real world, which allows the robot to safely fail, learn, and update itself. And finally, step 3, you flip the data flywheel. Because human video is the only layer cheap enough to learn from continuously, it is the absolute ultimate key to accelerating progress. Once the robot can teach itself just from watching us, the starvation ends. I really want to leave you with this final, somewhat provocative thought. Whoever cracks consumer-scale structured human video quietly powers every humanoid above them. Think about that. The hardware is ready, the algorithms are waiting. The true kingmaker of the upcoming robotics revolution isn't going to be the company with the shiniest metal robot, it's going to be the one who figures out how to feed it the right data. Thank you so much for joining me on this explainer today. Keep questioning, keep learning, and I'll catch you next time.